Hello, everyone, and welcome to today's webinar, HashiCorp Terraform and the 4 phases of the journey to collaborating on infrastructure as code. Please feel free to type your questions during the webinar. We compile all questions and answers at the end of the webinar and send the results to everyone registered. This webinar is also recorded, and the recording will be made available after post-processing, usually within 2 days. With that, let's go ahead and get started with Matcha from our team.
All right, so let's get started. So my name is Maciej Skierkowski. I'm the product manager for Terraform Enterprise. And what I want to do today is I'm going to walk you through kind of an intro to both Terraform open source, Terraform Enterprise. Going to go through the principles behind the two. I'm going to give you a little demo of Terraform Enterprise, including some of the collaboration functionality and governance, and then I'm going to hand it off to Jordan to kind of continue through the assessing and progressing through the journey. So first thing is, where does Terraform fit into the HashiCorp stack? So if we actually think about all the different challenges that we have with building and provisioning, Terraform is where we actually focus on the provisioning of infrastructure. And the typical challenges that we have there is with scale, heterogeneity, and dependency management. And so this is where Terraform really kind of, the main thing that we provide is provisioning any infrastructure for any application. And so now, before actually jumping into kind of the details of Terraform, one of the things that I want to do is just kind of set the stage of how Terraform fits into the HashiCorp product principles. So actually, give me one moment here to share this. And so if you look at all the different HashiCorp products, there are kind of 3 different things that we try to achieve. So first is codification. So with Terraform, the way this applies is we want to make sure that we take infrastructure and we are able to provision using code. Second thing is workflows, so providing a consistent workflow for provisioning. And then lastly, of course, making everything open and extensible. So the way that this applies to Terraform, so first is we have plan and apply. So this provides a consistent workflow for working with infrastructure as code. So whenever you make any kind of changes, you want to set any kind of resources, you can plan everything out first, and then when it looks good, you can apply. Secondly is Terraform itself, the architecture actually really aligns well with this design because we have the core and the provider split. So on the left side, we have the core, which provides that consistent workflow and language, and also the different providers. So this is the way that it looks, is we have the infrastructure as code, and so we have HCL as the way of expressing the infrastructure as code. And then on the other side, we have the entire extensible provider model that allows us to integrate with all the different providers. And so with this design, one of the things that's interesting is that basically we try to make sure that we have a consistent way of interacting with all these services while still providing and preserving the uniqueness of all the different resources. And so the entire, the providers are open source. We have over 70, I think 75 providers that we support. And there are literally thousands of resources within all these different providers. So that kind of sets the stage for Terraform open source. One of the things that I kind of want to talk about is how Terraform open source and Terraform Enterprise fit together. So this is a diagram I really like to use because what we see here is we have Terraform open source on the left side, and then we have Pro and Premium. These are our 2 enterprise tiers. And what we see here is kind of the value that we're adding there. So first is collaboration, and the second one is governance. And so I'm going to talk about each of those and how they apply to the product itself. So before I had the diagram where we go through the entire process of, infrastructure as code, going through the plan and apply, creating all the different resources. This all works well when you're using Terraform as an individual user. However, things start to get a little bit more complicated when you start increasing your team size, number of environments, different components, repositories, the configurations as a result, and of course a lot of states. And so the way that we kind of think about Terraform open source versus enterprise is that open source is really focused on addressing the operational complexity, while Terraform Enterprise is for addressing the organizational complexity. So how do you basically use Terraform at scale? So I think the best way to actually do that is through a live demo, which I love doing. So in here I have, what I'm showing you is Terraform Enterprise data. This is available today. It's under the under atlas.hashicorp.com. So what I'm showing you is the SaaS product. It's also available for private installs as well. And I'm showing you the beta as it is today. It is not available in general availability yet. So what I want to do is go through the entire process of creating a new workspace, connecting it to VCS, and then triggering a run, all in the context of Terraform Enterprise. So what I'm going to do here is I'm going to switch over to GitHub. So this is a project that I have in my this GitHub repository that I created. It contains a single file, main.tf. It's a super basic configuration. All we're really doing here is just defining one variable called name. We don't set a default value, so this basically makes it a required value, so we have to pass that in when we are performing the plan and apply. We create a random resource, and then we have two output variables. So that way later we can actually check what those outputs are. So this is a very basic example of a configuration, and what I want to do now is create a new workspace within Terraform Enterprise that uses this configuration. So I'm just going to switch back over to Terraform Enterprise, and what I want to do is create a new workspace, for lack of a better name. Just going to create a new workspace, provider name. We have documentation in terms of better naming conventions. I'm just using a very basic name for the sake of the example. And then what we do here is I'm going to select this project from GitHub, from this repository. Before the demo, of course, I configured the authentication model between GitHub and Terraform Enterprise. So Terraform Enterprise has access to my list of repos. And what we have, when I'm creating this workspace, we also have other options that we can set, including the working directory, VCS through VCS branch. So we can kind of configure where Terraform is being executed from. I'm not going to go into those details. We're just going to stick to the defaults. And I'm just going to go ahead and create this workspace. So behind the scenes, Terraform Enterprise connected to my VCS GitHub and it registered the webhook. If I were to make any kind of commit or a PR on that repository now, it would kick off a run. I'm not going to do that. We know that it's going to fail because we haven't set that required variable yet. So I'm going to switch over to this variables view, and I'm going to edit and so I just set a new variable for this workspace. What this is doing is, the Terraform variable is, you can kind of think of it as the equivalent to setting the -- variable on the command line for Terraform open source. So we're basically feeding in this variable into the environment that's going to be executing the Terraform plan and apply. Other than this, we also have two other types of variables you can pass in. First is environment variables. This is equivalent to using the export command on the command line. Typically, this is used for setting credentials on providers. So, for example, if you're using AWS, you can set AWS_access_key as an environment variable. That way, that provider will use that environment variable for the credentials. And then we also have the personal environment variables, which is it's also an environment variable. However, the difference is that with this workspace, right now I'm just using it as a single user. However, you can have multiple users that are connected to this workspace. And each of these personal environment variables is scoped to each individual user. So if another user were to log in and look at this exact same workspace, the set of variables they would see here would be different than the ones that I see. So we've set the variables. Next, what I'm going to do is I'm going to go ahead and queue a plan. And so what we are doing now is Terraform Enterprise is reaching out to GitHub, and it pulled my pulled that repository, pulled that configuration, and it automatically triggered the plan. I'm going to expand this. And so what we can see here is we see the output, the logs of running Terraform plan. So it provided that variable and executed the Terraform plan command under the hood. So we've done it, it's successful, and now we have the option to confirm and apply. So in this case, because it succeeded, we can do confirm and apply. It will execute it. I'm going to go ahead and do that. To do this, you need to have appropriate permission, so you can actually set it up so that not all users can perform the apply. I have permission to do that, so I click the confirm and apply, and that will execute the apply command, and we can see the view apply. And we see the entire output, and we see that it set those two output variables, the hello world. So it took that variable and executed that. So basically it did this entire process. So let me actually go back here. So we went through this entire demo, which we went through the process of creating a new workspace, connecting it to VCS. I also set a variable and then triggered a run. And so all of this was executed in the context of Terraform Enterprise. One of the things that I didn't show you is the team management. So this is really designed for working in a team environment. So you can have, you can create teams, you can give those teams various types of permissions to all the different workspaces and the organization. So that's the demo for the core Terraform workflow. So I want to go back to this slide again. So we were talking about all this collaboration functionality. And so one of the things is when using Terraform Enterprise, you can create a lot of different workspaces. You can have a lot of configurations and states and a lot of teams. And it just really helps managing the organizational complexity. And so one of the things that's interesting is when you start doing this and you start repeating this entire process, basically you can, in a larger organization, you can enable your developers and all the different teams to provision their own resources. Basically, we're enabling self-serving of infrastructure. And this actually creates new types of challenges, and that's really where governance comes into play. So we have introduced, about last month at HashiConf, we introduced Sentinel. It is a embedded framework for defining policy as code using a syntax, the Sentinel syntax. It is its own language. And what this Sentinel actually follows a lot of those same product principles as Terraform. So it allows you to express rules, your policies basically, as code. It provides a common workflow so you can also perform test and apply on those policies. And it's also extensible. So you can actually import your own modules to be able to integrate with any kind of third-party or internal services that get other data that you can define your policies around that. And so the language itself is, it's easy to learn. The logic is quite robust. You can express a lot of different rules with it. Yeah, so that's basically the Sentinel and policy as code. What I want to walk through now is how this actually applies to Terraform and Terraform Enterprise. So one of the things that I want to do is, if you are using Terraform Enterprise and you have enabled all of your users to provision resources, what you want to do is create policies that kind of make certain restrictions or rules around what can and cannot be done. So the first step in using Sentinel in context of Terraform is defining those policies. Once you have defined those policies, you save them to your organization, and so they become embedded as part of your organization, and therefore they are enforced on all of the runs. So in the first demo, I showed you a plan and apply. Once you set a policy of an organization, there's going to be an intermediate step, which is a policy check between a plan and apply. And so once you can do that, there's that check. And so if that check actually passes, the next thing that you're going to be able to do is it'll actually perform the apply with that level of confidence that you know that all the different resources you're provisioning are compliant with those policies. So that's kind of the overview of Sentinel and how it applies to governance and Terraform Enterprise. So what I'm going to do now is actually show you how that works in Terraform Enterprise. We're going to go back in here, go to Workspaces. So the first thing that I had mentioned is I want to define a new policy for provisioning those resources. So what I have in here is this is just a gist. I've defined a very basic Sentinel policy. What this does is it imports TF plan. This enables Sentinel to be able to reason about my Terraform configuration. So it's able to parse the configuration, the state, and the plan. And then what we do is we define this new rule. And what we're doing here is, so we're using the TF plan. We iterate through all the different resources that are of type AWS_instance. So these are basically all the AWS instances. And what we're doing is iterating through all the instances, and then defining the two rules. One is that the resource contains tags, and the second is that it contains billing ID. So what this policy is basically doing is, if I'm in a large organization and let's say I'm using, I have another system that handles all the billing for within AWS, and I want to define this billing ID in order to make sure that we can easily bill and attribute all the different resources to the appropriate teams within my organization. And so we were defining this policy to be able to say, you know what, we're going to use tags on all AWS instances, and we're going to use this billing ID tag to be able to do that, to identify those instances. So this is what this policy is doing. And what I want to do now is I'm going to switch over back to GitHub, and I'll show you a, I'm putting my operations / developer practitioner hat. And I've defined this different configuration here. What this configuration does is it basically creates a VPC, a subnet, and then most importantly, it creates a new AWS instance. And we define all this. One of the things that is in this AWS instance is this tags section, which I have commented out. So currently, this configuration has no tags defined on it. And that's where we want to enforce this policy on this configuration. So I'm going to switch back to Terraform Enterprise. What I have on here is I've created this webinar app. And I've already connected it to this repository, and I've also set my credentials in here for AWS. So what I'm going to do now is actually set this policy for my organization here. So we have this organization called Webinar Demo, Sentinel Policy. So I'm going to create a new policy. And I'm going to take this policy that we defined here. And I'm going to set this here. So give it a name. And what we have is there is a drop down here for defining the enforcement level. There are basically 3 different levels of how I want this policy enforced. So the first is hard mandatory. This basically means that this policy must be, everything must be compliant with this policy, and there are no exceptions to that rule. The second is soft mandatory. What this means is this policy will, if it fails, certain users will be able to override it. Those certain users are people who have appropriate permission, which are the admins on the organization. So the idea is, under certain circumstances, let's say you define a policy that says that you cannot do any deploys Friday through Sunday. You just don't want anybody pushing anything out over the weekend. However, if you have some kind of emergency situation where you need to do that, you would probably set that policy as soft mandatory so that a admin can actually override that policy as needed. And then lastly, we have the advisory, which is more about providing information. So this is just kind of helping the practitioners understand what the policies are and how they should be using them. However, it will not block a apply from happening. So for now, we're going to actually use the hard mandatory to set this new policy. I'm going to set the policy. So we've set this policy. I'm going to go back to this app, and I'm going to queue a new plan. So what this is doing now is it took it pulled the configuration from my repo. It kicked off a new run. And so we're going to see this plan. So you can see the plan that it actually generated. So it's creating the VPC subnet and also this new AWS instance. And then we're going to scroll down here. And because we have defined this new policy, there's this new intermediate step called policy check. And I'm going to view this check here. And so what we see here is that that one policy was evaluated. That's the one that we've defined, the billing ID tag required policy. And the result was false, meaning that we did not comply with this policy. Now, at this point, we're blocked. We cannot continue performing and apply. Had I set this as a soft mandatory policy, and if I was an admin, I would actually have a button here that would say override and continue, and would actually allow me to override this policy and continue even though it was red. That's only if it's set on soft mandatory and if I have appropriate permissions. So now that we have that, what I'm going to do is I'm going to go back to this configuration. And I'm actually, so as a user, I'm creating this configuration, created this run, it wasn't compliant, so now I say, oh, okay, I actually have to fix my configuration in order for it to be compliant with this policy. So I'm going to set these tags here. So I committed these. So I committed this change in this VCS, and I added the appropriate tags. I'm going to switch back over to here. So once we actually have done that, I'm going to start here. So there we go. Yeah, so because we're using VCS and because we had the webhook already set up, Terraform Enterprise picked up that change and went through that entire process. So we see the plan. The plan looks exactly the same as we had it before. It created it defined the AWS instance, VPC, and subnet. But now, when we go into the policy check, we see that it is now, that the result is true because my configuration is now compliant with this policy. And as you can see, we have the confirm and apply button available here. So now I can actually click confirm and apply, and we'll go through the entire process of provisioning those AWS resources. So I'm not going to do that because that takes a moment. So let's just skip that part. Yeah. So so this demo basically showed me using Terraform Enterprise, defining a new policy which required me to have tags and that billing ID tag set on all AWS instances. I went through the 3 levels of policy enforcement, and then we went through the entire process of going through a run, plan and apply, and that and the intermediate policy check. So that's the intro to Terraform open source and enterprise, the collaboration and governance functionality. And I kind of wanted to show you those demos just to show you how this actually looks like, how collaboration and how governance actually looks like within Terraform Enterprise. Now I'm going to hand this off to Jordan to guide us through assessing and progressing through infrastructure as code.
Awesome. Thanks, much. Right, so hopefully everybody can see my screen. Can you see my screen, Mathieu?
Yep, looks good.
Awesome. So you've probably seen the post recently about Terraform recommended practices. And so this is kind of just to introduce that on how it can help you assess your organization and also progress your organization on the journey of infrastructure as code. So before I do any introductions, I just want to justify the value of listening to this presentation. So most of us are already playing with Terraform and we love the tool, but from experience, there's a lot of pain when it comes to actually scaling Terraform in the enterprise if it's not done correctly. So for example, production environments being destroyed, spend being a lot bigger than you expect it to be, and also the guys who are actually paying the bills don't actually know what is running in their cloud. And so this gives some insight on how you could actually work towards keeping all of these things at bay. So I'm Jordan Taylor. I'm a DevOps practitioner from Contino and the HashiCorp practice lead. And who are Contino? So Contino are an enterprise DevOps and cloud transformation consultancy based in the UK, USA, and Australia. So we focus on regulated enterprises with the successful adoption of DevOps and continuous integration. So we're also a HashiCorp system integrator partner, and the reason that we can speak about this kind of stuff with Terraform is because we've implemented these tools across over 70 engagements now. So assess and progress, what am I actually talking about? So the Terraform Recommended Practices Guide gives organizations a self-assessment across 23 questions to actually see where in the journey of infrastructure of code they actually are. And so with this insight, they then know the next steps that they need to take on their roadmap to collaborative infrastructure as code. And so the 4 phases of the journey tend to be manual. So at this stage, everything is heavily manual, and pretty much there is no infrastructure as code in the organization, and there is zero traceability almost in your environments. Then it goes to semi-automated. So at this stage, you've got some manual, but also some infrastructure as code in the labs of the organization, and then there will probably be multiple solutions to the same problem. So there's just a lack of unification across the organization when it comes to how you provision your infrastructure. And then you move on to infrastructure as code. So at this point, you're probably hitting the more mature levels of Terraform open source. So things are fully automated, everything's consistent, and you also have a lot of reusability. But that's just in a few teams. So when it actually comes to multiple teams and the whole organization needing some compliance around how people provision infrastructure, this is where you move on to the collaborative infrastructure as code phase, where you need tools like Terraform Enterprise. So when you use the best practices guide, a typical assessment that I have seen personally is that, let's take Bank X, for example. So the organization has long lead times to get new infrastructure. There are teams using Terraform. There are a lot of fans within the organization playing around with Terraform, but you work in a heavily regulated and process-driven environment. So actually making any big changes in the organization are tough to get through. But at the end of the day, you need to deliver code more effectively and more efficiently, so you need more speed. So as a taster, I'm just going to go through a few questions just to show you the kind of things that you will be assessed on. So question 1, how do you currently manage your infrastructure? So as Bank X, I know that it's not number 1. We do use command line scripts and a combination of UI and infrastructure as code. We're playing with Terraform in the labs, but a lot of the guys will just go to the UI, change security groups, and then when I run my Terraform again, things are broken. Question 2, what is the process for implementing changes to existing infrastructure? So I know that we have configuration management. We've got a lot of Puppet running from the sysadmin end, and there are some guys that are using Ansible from the development teams at the minute. And so that's pretty good. How are changes promoted through the environment? So we're quite good here. We've kind of nailed the idea of no manual changes to the environment. So developers test locally first, and then it goes through UAT. staging, and then production. But we don't have deployment pipelines all the way through to production. There are still manual steps within each of the progressions between the environments. So after that short 3-question assessment, I can see that we have the majority of 2s. So I answered number 2 more than any other. I answered 1 number 3, so we're at the top end of the 2, which means that we're semi-automated. So we have some infrastructure as code, but we're lacking unification. We also have some configuration management, but we're not completely manual. We're making progress. And so how do I progress to the next phases of infrastructure as code? So I'm going to start right from the start. So let's pretend that we didn't do that assessment. We're now a manual, right? So we're going to start from day one. So when you build an infrastructure manually, it's very hard to audit, and it's also very hard to kind of keep control over who's doing what. And if you can't keep control over who's doing what, then it's going to be hard for you to scale while also remaining compliant and secure. And sharing knowledge of how everybody is doing things is also very ad hoc. It doesn't really happen. An email here and there, it's not really controlled. So how do you get to the semi-automated phase? So obviously I'm going to say install Terraform, because Terraform is how everybody should do infrastructure as code. And then you should start and play around with some Terraform configurations, build in a few instances after reading the Getting Started guide. But then you want to take your first small project, whether it is just, I don't know, a small team with a fresh application, the first people into AWS, let's say, just implement that first piece of infrastructure into whatever your cloud provider is, using Terraform, just to get a feel for what it is to automate your infrastructure provisioning. So at this point, you are semi-automated. You have some guys that are automating the process of provisioning infrastructure. And so you have a small but meaningful subset of infrastructure, which is managed as code, but the majority of guys are still doing a lot of manual stuff, and the practices aren't ideal. So how do we get to the phase of infrastructure as code from where we are now? So most people would already be using version control as soon as I mention the word code. But if you haven't already, everything when it comes to configuration code or infrastructure code should be in version control. Put all of your Terraform configurations into a version control system, and then you should also look to start and move to Terraform modules. So just to kind of illustrate the Terraform modules approach, when should you actually write a module? So if you're writing a module for reusable code, are you writing a module for reusable code? Yes, you are. Is it small? Then no, it's not. It's a full network stack. So is it an architectural pattern? Yes, it's a full network stack. And so you would write a module in this case. But you will find that there are 2 types of modules. So you have core modules, which are reusable by everybody. So they could be the VPC modules that the HashiCorp guys put on their module page, or it could also be a contextual module. So relevant to your organization, but it makes use of, it inherits from core modules. And so this diagram is also in the documentation, but this gives some insight onto when to know when to write a module with Terraform. And so at this stage, we're still semi-automated. Everything's in VCS, and we're starting to write modules. But we need people to know about Terraform and about the practices that we're going to start using with Terraform. And so at this stage, you can start to get everybody into a set of compliant habits. So they should be starting to do test-driven development. So your Terraform configurations can start having unit testing and integration testing as they're going through development, through test, into production, let's say. At this stage, you should also look to use configuration management as well. So if you already have it in the organization, that's great. You can start and use that with Terraform. But if you don't, then now's the time that everything within a host should be managed by configuration management or some sort of automation. There should be no manual changes happening on boxes at this stage. And also, people have secrets in code, whether it's database connection strings or generally managing the access to the cloud provider via the API, so your access keys and your secret keys. These things shouldn't be out in the open, and to be honest, they shouldn't be static, they should be dynamic. So this is where HashiCorp Vault comes in, where you can actually create these database credentials or AWS credentials, if you like, dynamically, or you can just store things in an encrypted fashion in the KV store. But at this point, we're now at infrastructure as code. It was quite a tough journey, a lot of changes, but we're at a good point. But we only have a few teams that are really strong, and to be honest, those core teams, they don't have unified practices, and they don't have, so the guys from above, they don't have any visibility as to what is actually going on, and they don't really have much control over their cloud, even though they're paying for it. And so we have at least one Terraform module, so a few guys have made a lot of progress. And there is much more visibility because all the infrastructure is now as code, but only to the technical guys who can read that code. And so now we're at a stage where we want to go to collaborative infrastructure as code, so where all the teams can collaborate and where there is much more visibility. So at this point, you don't want to solve this problem again, because lots of companies have come together and said, we have these pain points with Terraform. And HashiCorp have listened, which is what Terraform Enterprise is. It kind of tackles all of the problems that everybody is hitting when they start to scale their automated infrastructure as code provisioning. So once you understand Terraform Enterprise run environment, you'll realize that how you split your repositories or your workspaces, which is another word for it, is the most important thing. So as Maciej said earlier, managing the Terraform state when you have lots and lots of states is a big issue. And how people use the metadata from those states is also key. So you can see down the right here is a few examples of how you would split the workspaces. So the networking team would have their own workspace. The billing team have their own workspace. The security team would have their own workspace. They're all managing any networking related configuration in the cloud provider, security related. But let's go back to networking and say, okay, we provision the underlying VPC. You guys can use this set of subnets. And that's in that Terraform repository. But then the team over here also need the values from that networking repository. And so that's where Terraform Enterprise will handle sharing that metadata between the two. And everybody has their own individual workflow to get new code through the lifecycle as well. So not only are people able to test on their own software development lifecycle, they can also inherit from other people's repositories or other teams' repositories easily. And at this point, you can create the workspaces as well. And once you created the workspaces, you know who in that team should have which permissions. So let's take, for example, the networking prod guys down here. So a networking engineer is able to read the repository, that's fine. And when it comes to the owners of the networking, they can read and write. And then the central IT have admin over it. So the team owners here and the central IT guys are the only guys that can say, yes, you can perform and apply in networking on production. But just the engineers, they won't have the ability to make any direct changes to production because not only there's probably some policies that have been applied to make sure that certain changes can't go into production unless certain things happen anyway, well, there should be. And also only particular guys should be able to make those changes and perform those applies as well. And also the final stage is restrict any non-Terraform access. So what am I saying here? What I'm telling you that once you get to a maturity level with Terraform, you should no longer be able to do anything with the cloud provider unless you're doing it via Terraform. So that way you get to apply compliance all the way through the pipeline. Any change that needs to go to production has gone through a series of validation from unit testing, from integration testing, and from Sentinel as well. So you know that all of your policies are being adhered to as well. And then once it gets into production, why would you need to log into the UI to make a change when you know everything is as it should be? So that is the end goal. And that's it. So that's infrastructure as code in a collaborative fashion. So we've scaled it to multiple users across many data centers. teams are building all of their infrastructure without any conflict or any risk between each other. So the guys who are paying for the cloud and get the most value from the cloud are getting the governance and auditability factors that they need, because everything is all building from one place. They know who is doing what, and they also know that testing and policy tests are being applied all the way through the process. And so Terraform Enterprise, why do Contino think that it's really going to make a difference in the enterprise? So as I said before, so multiple teams are able to manage their workspaces, their Terraform states. You have secure variable management natively, so Vault is running under the covers to manage the variables in the encrypted fashion. And then you've got everything's auditable as well. And then with the permissions that people have on workspaces, X person can't run and apply at this time if you set it with Sentinel, let's say. All that role-based access control that everybody needs in the enterprise is ticked with this tool. And also, the kind of the softer view of it would be that it changes the culture and mindset around infrastructure as code. So infrastructure is code now. Configuration is also code, should be, and your application code is code. So they should all follow the same life cycle. They should all be tested. They should all have pipelines all the way through to production. Nobody should be making manual changes. Everything should be treated as code with the same software development lifecycle. And so go and check out the Terraform Recommended Practices Guide and just give your organization or your teams a self-assessment to see where you actually are on the journey. And then from there, you can kind of see, oh, we're doing quite well. We're already at an infrastructure as code phase. But if you're not, then maybe you need to start and look at how you can collaborate effectively with Terraform, with something like Terraform Enterprise. And so thanks for listening. So if you've got any questions from the Contino angle, if you're kind of quite low in the maturity scale when it comes to infrastructure as code, then feel free to contact us. But if you feel like your organization is already at a level where you just need the tool, you need Terraform Enterprise, then contact the guys at HashiCorp. Thanks for listening. Thanks, Amanda.
Thank you, Jordan. Thank you, everyone, for joining us today for today's webinar, and thank you to Matcha and Jordan for presenting. As I mentioned at the beginning, this webinar was recorded, and we will make the recording available after processing. We will also send an email to everyone who registered for the webinar, the complete list of questions and answers after we summarize all that data. Thank you so much for joining, and have a great day.